Welcome to Chapter 5. In this chapter, we will begin to explain the second section, filament. The first section content can be understood as adjusting the printer parameters according to the printer series to achieve the best printing effect. The second section content, you can understand it as the adjustment according to your filament type. In this section, you can access the configuration parameters of any Minga filament by clicking the menu button. For D-series printers, there are two options below the menu button, corresponding to the printer's TO and T1 extruders. For the Add F for series, there are four options, corresponding to the printer's TO, T1, T2, and T3 extruders. If you have pre-selected the filament profile already, the corresponding filament will be displayed in the drop-down options. The right side button is used to bring up the Material Settings menu, where you can modify parameters for the current filament. The profiles in this menu are the key content of this chapter. In the menu, the most important are the first two parameters. For these to selection ease. The main function of the filament section is to record and adjust the basic parameters of the currently selected filament. The first item is basic information. Most of the content under this item is used to record and define the consumable, and modifying them will not have any impact on printing. The second item is flow ration and pressure advance. Most printing quality issues arise because these two parameters under this item are not set correctly. Flow ratio is used to adjust the filament flow rate during printing, which directly affects surface quality. Here are some samples as the reference. When the flow is too high, over-extrusion will occur. When the flow is too low, under-extrusion will occur. When the flow rate is balanced, the printed surface quality will be optimal. We will cover how to calibrate filament flow rate, as well as other calibration-related part mentioned in a separate dedicated chapter. Pressure advance is used to resolve print quality issues caused by extrusion pressure lag. Let's briefly explain what extrusion pressure lag is. During acceleration, extrusion pressure lag leads to insufficient filament deposition, resulting in gaps or thin lines in the print. Otherwise, during deceleration, residual pressure causes excess filament to ooze out, leading to blobs or stringing. These issues worsen as printing speed increases. So pressure advance adjusts the extrusion rate in real time based on both acceleration and deceleration phases, thereby resolving these print quality problems. Pressure advance also has a corresponding calibration method, which we will introduce. The two parameters mentioned above are key to improving print quality. When using third-party filaments, we recommend calibrating the filament to achieve better print results. Print chamber temperature depends on whether the printer is equipped with a constant temperature chamber function. Currently, the D-series printers and at F4 model do not have this function. Print temperature is used to set the nozzle temperature during printing, which is divided into the temperature for the first layer and the other layers. Bed temperature is used to set the heated bed temperature, also split into the temperature for the first layer and other layers. Typically, to make the bed adhesion better, the nozzle and bed temperatures of the first layer can be higher 5C 15C than other layers. The last item is volumetric speed limitation, which involves a new key concept, volumetric speed. Volumetric speed is the rate at which filament is pushed through the hot end and extruded onto the heated bed. The hot end has a physical limit. If you try to extrude more material, then it can melt. Some printing problems like under-extrusion, weak layer bonding, or surface defects will occur. It is at the heart of balancing print speed with print quality. To know the maximum volumetric speed of the third-party filament, we should also make the calibration. We will mention it in subsequent chapter. Next part is cooling. All settings under this part relate to the cooling fan. Modifying these parameters will also affect print quality. Cooling for specific layers controls the layer at which the cooling fan starts operating. No cooling for the first disables the fan for the layers before the set value. Full fan speed at layer, the fan runs at full speed once printing reaches the specified layer. For example, if the first setting is 2 layers and the second is 5 layers, the fan speed will gradually increase to full speed from layer 2 to layer 5. If the layer number in the second setting is higher than the first, the second setting will be ignored. The fan will run at full speed starting from first setting value plus 1 layer. Part cooling fan controls the cooling fan's efficiency at different stages of printing. Min and max fan speed threshold. The minimum and maximum operating power of the fan during printing. Fan speed sets the fan power. Layer time, when the printing time of a layer is higher or lower than the set value, the fan runs at the power specified in fan speed. For example, if the first fan speed is 40% with a layer time of 12 seconds, and the second fan speed is 60% with a layer time of 5 seconds, the fan runs at 40% efficiency when a layer's printing time is lower than 5 seconds or runs 60% when the time is higher than 12 seconds. For printing times between 5–12 seconds, the fan efficiency adjusts proportionally between 40–60. Keep fan always on. When enabled, the cooling fan runs at minimum power throughout the printing process even if fan speed is set to 0%. Slow printing down for better layer cooling when enabled. No layer's printing time will be shorter than the value set in min fan speed threshold. For example, if a layer's original printing time is less than 5 seconds, the printing speed will be reduced to extend the layer time to 5 seconds. This setting is linked to the min print speed below. When slowing down printing, the speed will not drop below the set min print speed. It is also associated with don't slow down outer walls. When that function is enabled, the speed for printing outer walls will not change due to the min fan speed threshold setting. Force cooling for overhangs and bridges. When enabled, the fan works at the set speed when printing overhangs or bridges. This involves 2 technical terms, overhang and bridge. Overhang is an inclined structure of the printed part that extends outward from the main body with no support underneath. Bridge is a narrow, fully suspended structure of the printed part that connects 2 points with no support in between. Overhang cooling activation threshold. The fan is activated when the overhang angle exceeds the set value. The following 4 settings correspond to the fan speeds for printing overhangs: external bridges, internal bridges, support interfaces, and ironing, respectively. Auxiliary part cooling fan sets the operating power of the auxiliary cooling fan. For D-series, the auxiliary cooling fan is located at the rear of the heater bed, providing powerful cooling performance. The AD-F4 does not currently have an auxiliary cooling fan. Exhaust fan enables the exhaust fan inside the machine. It allows setting the operating efficiency during and after printing, respectively. The above filament and cooling are the 2 most important parameter categories in material settings. Other parameters have a relatively minor impact on the printed model, so we will briefly explain their functions. Setting override matches the content of the extruder section in the printer tab. You can check Chapter 4. If different parameters are set in extruder and setting overrides, the latter will override the former during printing. Advanced is similar to the content in the printer tab. It is also used for commands executed by the extruder before and after printing. We don't recommend making any modifications or adding custom commands in this section. Next is multi-material. This function provides auxiliary options for multi-filament printing. Wipe tower parameters. The wipe tower cleans the nozzle when switching filaments during printing. We will explain how to set up the wipe tower in the next section. In addition to configuring the wipe tower, the other two settings under multi-material are integrated into the printer configuration file. Modifying these parameters will not have any impact on printing. The last item, dependencies, limits the printer models and process configurations compatible with the current filament settings. This function prevents incompatibility between user custom filament parameters and the machine, which could lead to unpredictable issues. As of Orca Slicer version 2.3.2, this function is still in the testing phase. We do not recommend users make excessive modifications to these parameters. The above covers all configuration parameters in the Filament section. In the next chapter, we will begin explaining the various parameter settings in the Process section. Thanks for your watching. See you next time.